Section 5.3 Interactive Assignment Objective 2. The probability that a randomly selected 4-year-old male salamander will live to be 5 years old is 0.96695. In Part A, it says, what is the probability that 2 randomly selected 4-year-old male salamanders will live to be 5 years old? In Part B, it says, what is the probability that 6 randomly selected 4-year-old male salamanders will live to be 5 years old? Let's take a look at the question here. Okay, so we're looking for the probability that 2 randomly selected 4-year-old male salamanders will live to be 5 years old. Now, what is the probability of selecting 1? Well, the probability of selecting 1 is 0.96695. So, we're going to let event E be 1 randomly selected 4-year-old male salamander that was going to live to be 5 years old. And we're going to let event F also be another selection for when the 4-year-old salamander will live to be 5 years old. Okay, now we know that events E and F are independent. And the reason is because the occurrence of event E in a probability experiment does not affect the probability of event F and vice versa. Okay, so we know that the probability of E is 0.96695. We know the probability of F is also 0.96695. So what we're going to do is, since E and F are independent, we're going to use the multiplication rule to find the probability that both event E and event F occur, and then we're going to round our answer to 5 decimal places. So we're going to take the probability of event E times the probability of event F, okay, because the probability of E and F represent that multiplication rule. So we know we're going to take the probability, which is 0.96695, and multiply it by the probability of 0.96695. So let's go ahead and do that. So if we take 0.96695 and then we're going to multiply it by 0.96695, okay, what does that give us? We're going to round this to 5 decimal places, which is 0.93499. Now if you take a look here, that is what we get for our result. Okay, now another way of doing this is by taking the value of that probability and then raising it to the second power, because we're looking for 2 randomly selected 4-year-old male salamanders. So we're going to get the same result if we take this 0.96695 and then squaring it, and you will see we get the same result. So therefore, we're going to say that the probability that 2 randomly selected 4-year-old male salamanders will live to be 5 years old is 0.93499, and then we can check our result there, and there is our result, 0.93499. Okay, now the second part, okay, is the following. What is the probability that 6 randomly selected 4-year-old male salamanders will live to be 5 years old? We'll find the probability that 6 randomly selected 4-year-old male salamanders will live to be 5 years old is a generalization of Part A, meaning that since there's 6, we're going to take event 1 all the way to event 6 and multiply them together because they are also independent. So we're going to say the probability of all those events is going to equal the probability of each of those events multiplied by each other. So how many independent events do we have? Well, we know that n is equal to 6. So we're going to take those probabilities, right? So we know that all the probabilities are the same, which means that the same events happen to different randomly selected individuals. So this means that the n is equal to 6 probabilities, okay, is going to, each one of them is going to equal 0.96695. So we're going to take the probability and take each one of those probabilities and multiply them by each other 6 times. So we can do it like that, or we can shorten our math and say, okay, we're going to take this probability and then we're going to raise it to the 6th power. Okay, so let's go ahead and do that. We're going to take 0.96695 and then we're going to raise it to the 6th power, and then we're going to round it to 5 decimals. So it's 0.81738. So let's see what we get. So 0.81738. So that means that, therefore, the probability that 6 randomly selected 4-year-old salamanders will live to be 5 years old is 0.81738. Let's verify our result here on StatCrunch, and therefore there's our result, 0.81738.